So Mars Reconnaissance Orbiter has made a fortuitous discovery of 5 craters, very small craters from about jacuzzi to about swimming pool size. And we've seen hundreds of these kinds of craters, but we found 5 very special ones in that they had fresh ice in the bottom of them.
So we started monitoring this material, and sure enough, it faded away like you would expect water ice to fade away. It sublimates into the atmosphere since it's unstable at the surface. And also, a third instrument on Mars Reconnaissance Orbiter, the hyperspectral imager called CRISM, was able to get a spectrum of one of these deposits, one of these new water ice exposures. And the spectra that instrument got proved that it was water ice, as we were expecting.
We found water somewhat closer to the equator than we were expecting to see it. And what that tells us is that water is not stable with the conditions on Mars now, with the amount of water in the atmosphere, with the climate on Mars today. So it's telling us that that water is kind of a remnant of a past climatic period on Mars when it was a little bit colder, ice was stable a little bit closer to the equator, and there was a lot more water vapor in the atmosphere. So we're seeing a window into Mars's past history by locating the ice at this depth.
The Viking lander landed in a place where, based on models and the results from these craters, we expect the ice table depth to be maybe about 25 centimeters below the surface. So maybe about this much below the surface. And Viking had a robotic arm, and it did dig down, but it only dug down about this much below the surface. So we think now that if Viking Lander 2 had dug slightly deeper, it would have discovered this ice about 30 years ago.